What's up, stats? This is Mr. Carlson, C Squared Mathematics, and we are on our very last lesson of the course. So this is the last lesson of Unit 8, but it's also the last lesson of statistics as a course. So you've made it this far. Congratulations. Now we're going to go through our last lesson. It's kind of wrapping up everything that we learned yesterday with 9.1 correlation, and we're actually going to be using some of the data that we discovered and found in our examples in 9.1. So it's kind of going to be a build on thing, but it's just as easy as 9.1. You're using Desmos all the time. As you can see, I have Desmos already pulled up. So we're going to be utilizing that all the time, a lot. I can't wait to get started. Let's go to town. We're going to skip the bell work and go straight to the homework quiz. It's just going to be 9.1. If you have any questions on that, let me know. But review your answers, send any partial credit requests towards me, then begin your notes for 9.2. What is a linear regression? So how do I calculate the correlation coefficient and a regression line for the set of data points? So this is our recurring essential question for the last couple of days here. And now we're going to get into not just the correlation coefficient, but how does the correlation coefficient relate to what I call the regression line or the trend line or the line of best fit. They all mean the exact same thing. And I love this meme. If you have ever watched anything from Dave Ramsey, that's who he is. He's amazing. So these data are so raw, DJ Patel could not train a linear regression with it. Okay, I love that. I love that meme. It's so funny. Let's get started. What is a linear regression? Okay, so where do they come from? Well, after verifying that a linear correlation between two variables is significant, like strong, like if it's strong or weak or whatever, and that's what we did yesterday. The next step then is to determine the equation of that line. So if you found that a linear scatter plot is strong and significant, okay, then what is the line within those data? What is the line? Specifically, what is the best line that represents that data? So I can actually predict and model certain factors. So I can predict in the future, okay, if this is how the data basically proceeds, let's predict based off of this determined set of data, let's predict to see whether or not this would come about. Let's just say that this would come about, say, in 2006 or 2007, that this data would occur given this set of points. I can literally find that out. Okay, I can find that out, which is very, very interesting indeed. So what does this mean? This line is what we call the regression line or the trend line. And its equation can be used to predict the value of y for any given value of x. So although many lines can be drawn through a set of points, obviously, if I have a scatter plot of data, I can draw as many lines as I want in those lines. However, a regression line is determined by a specific set of criteria so that it's what we call the best line. What is that criteria? How do I know what is the best line? Well, we use what we call the residual. The residual is right here in this little plot, the E. So this looks very confusing, but it's not. So let's just say I have a Y and a B and an X, okay? These little black dots are my scatter plot. That's what we learned yesterday, right? Now my regression line is what's in blue. Now, dependent upon how far this regression line is from each dot, tells me what we call the residual. And I'm going to get into that in a little bit. That residual, if it's the least sum of the squares of all the residuals, if it's the least sum of squares of all residuals, I'm going to say it again, if it's the least sum of squares of all the residuals, if I square these errors, these E's, if I square all of them and I add them all up, okay, and then I do another line and I square all of them and add them all up, all right, if I do that over and over and over again with all these different lines, you will eventually get one line, one perfect line that is the best, and that is the least sum of squares of all the residuals. That is my regression line. So let's get to it. What is the regression line? Consider the scatter plot and the line shown below. So it's actually going to be on the right here. Okay. For each data point, DI represents the difference between the regression lines and what we call the predicted Y value for a given X value. These differences are called the residuals. So these D's, these differences, sometimes we call them the E, the error, the observed Y value. So the observed Y value is my actual dot. Okay, that's my actual dot, my actual data point. Okay, my predicted Y value is my regression line. That's what we're going to learn today. It's my line that I kind of go through some points, but some other points I actually don't go through. Okay, but that's my predicted Y value. Okay, that D there, if it's really, really small, that means it's the closer, the smaller the D value, the smaller my error is between my observed and my predicted. The smaller this value is, and the smaller values I have all throughout this regression line, the better the line is. Okay, the better the line is. So let's find out what the properties are given these regression lines and these residuals. So let's go here. So what are the characteristics of a residual? Well, a residual can be positive, negative, or even zero. My error of my regression line can be positive, negative, or zero. When the point is above or below the line, my error, DI, is either positive or negative respectively. So if it's above, my error is positive, and if it's below, my error is negative. When the observed Y value, the actual Y value that I have from my data, is predicted, equals the predicted Y value, this is going to be DI equals 0. So when my observed Y value equals the predicted Y value, it's DI equals 0. What that means is if my regression line literally goes through a solid point. So if my regression line goes through a solid point here, my regression line, my predicted line, goes through one of my actual data points on my graph, that means my error is 0. Of course it's 0 because it doesn't go above and it doesn't go below. Okay, it's just straight up at that point. Of all possible lines that can be drawn through the set of points, the regression line is the line for which the sum of squares of all the residuals is what we call a minimum. What will that look like? We can do a short little formula here. So that means the sum of all my errors squared equals the minimum. So it's the least amount. So this right here, the least sum of the squares criterion is what tells me the best line, Okay, I can draw as many lines as I want through all the data points, but the best line, the regression line, that thing is going to be utilizing what we call the residual. Okay, the least sum of squares. Okay, and that's going to be the smallest amount. So for a given Y value, for a given X value rather, E equals the actual minus the predicted. Now E, of course, is the residual. It's my error. So is the actual, my observed point, minus my predicted line. Okay? We don't really calculate residuals that much. Like, we're not honestly going to calculate residuals at all. I'm going to show you how to find them, but we're not going to be calculating all of them at all. This is basically just a background information of how we actually come to get the regression line. We come to get the regression line through residuals. Okay? And that's all. So, regression equations. A regression line is also sometimes called the line of best fit. So this is what we call the line of best fit. It is the line from which the sum of the squares of the residuals is a minimum. I already said that, the least sum of squares criterion. So that is where we get the regression line. We choose the line of best fit in which the errors are the least, right? The residuals, the errors, the residuals mean the same thing as the errors. The residuals are the least. In Algebra 1, now you learned how to write linear lines. You learned that you can write an equation of a line by finding its slope m and its y-intercept b. The equation has the form of y equals mx plus b. Okay, so this equation has the form of y equals mx plus b. So we are going to be utilizing this very similarly. However, we're going to change one little thing. So recall that the slope of a line of the ratio is its rise over its run. So that's the slope. The slope, m, equals rise all over run. While the y-intercept is the y value of the point at which the line crosses the y-axis. It is the value, the y value, when x equals 0. So that point is just 0 and then b. Okay, so 0b, whatever my b value is, that's my y-intercept. The graph below shows an example. So let's erase and let's see the graph. So this is your rise over run, and this is exactly what you learned in Algebra 1. Okay, you learned all of this. So also in Algebra 1, though, you use 2 points to determine the equation of the line. Now, in statistics, you will use not just 2 points, but every point in the data set to determine the equation of the regression line. Okay, so instead of determining 2 points, if I want to find the best line, I can't just arbitrarily or randomly pick 2 points in my scatter plot and then say, hey, I'm going to draw a line through it, because that may not be the best line, right? That may have a bigger residual or a bigger error. I need to find the regression line with the least sum of squared errors, the least amount of error. That's going to be my best line. That is only one line per scatter plot. There's only one perfect line no matter what, and that is my regression line, my line of best fit. So let's go to town. The equation of a regression line. How do I get the equation of a regression line? Well, first of all, you're going to be using Desmos. Second of all, this is how you do it mathematically. The equation of the regression line, the best fit line, is an independent variable x and a dependent variable y. But because Google Slides can't allow me to do this, this is technically y hat. So it's y hat equals mx plus b. So this is my regression line. And you'll see something very similar to this on Desmos. You'll see something like this, where it's y1 and then a little like tilde and then mx1 plus b. So this right here is going to be what we will utilize for Desmos. And it does depend on what your table is. If your table is x2 and then y2, then you'll use x2 and y2 in here. If your table says, of your scatter plot says x7 and then y7, you'll use y7 and x7 for your regression line for Desmos. Okay, but more on that later. So where y is a predicted y value, so y hat is a predicted y value, and the slope m and y-intercept b are found using Desmos, like I just said. Okay, so I already explained all that. So while we primarily use the linear regression in statistics, and we will only use the linear regression in this lesson, we can also use different types of regressions. So for instance, we can use what we call the quadratic regression. We can use an exponential regression, a logarithmic, a power, and then also a trigonometric. Now these are very, very advanced ones, and if you're in honors, then you would be doing these, but you do not need to do these if you're in regular, general, non-honors class for me in stats at MHP. You'll primarily only be using the linear line here, okay? Sometimes we will have homework assignments where we will dabble with maybe an exponential or quadratic linear regression, but primarily we are going to only be doing a linear regression, especially for this lesson. All right, so let's get started. Remember this? We've been using this for a while. Okay, so this is the GDP, the gross domestic products in trillions of dollars, and this is the CO2 emissions. What I want to do is use this from 9.1, example 1.1. This is the exact same table. I have this over here on Desmos, just like I have it right here. This is the table. See this? This is my data. I'm going to use this, okay? I'm going to use this data, and I want to find the equation of the regression line. Find the equation of the regression line for the gross domestic products and the carbon dioxide emissions. How do I do this? Here's how you do it. First of all, what you're going to do is you're going to get a blank little, after you make your table on Desmos, after you make your table, you're going to get a blank little graph here, or little space, as it were. Get a blank space. See this? Down here, if I move down, get a blank space. After that, you're going to type in y. Now notice I have on my graph y1. See my cursor right here? My cursor is y1 and x1. So what do you think I'm going to do? I'm going to type in y1, and then I'm going to do a little regression symbol. So that's like a little tilde. It's right above your tab button. Just do shift and then click on the button left of 1 on your keyboard. And then M, because that's my, notice what's starting to happen here. And now I'm going to do X1, because it's X1. Look at that. And now I'm going to do plus, wait for it, B. Here, what happens is it actually gives me my regression line. This right here is my regression line, and it is beautiful. You're maybe wondering, what is that? Well, watch. My regression line is this. Y hat equals 116.900x, and then plus 115.725. How do I get those numbers? Right here. Right there. See where I put my cursor right there? These two numbers. My M is this, my B is that. And if I want y equals mx plus b, my slope is 166.9, and my B, my y-intercept, is 115.725. That's awesome. That means this is the best possible line. This is the best possible, I'm going to move my little face right here. This is the best possible line that I could create. The best possible line that has the least amount of errors in this line. It is a little bit on top, a little bit on bottom, but it is literally the best possible line here. This is just awesome. I mean, this is great. That means we can use this line and predict certain values. Honestly, we can predict certain values, and this is really, really great. Okay? One last thing, and this is really, really cool. Ready? We can actually plot my residuals. So I can plot my residuals here, and this is amazing because these residuals are my little purple dots. Again, we're not going to be touching on these a lot, but these are my little purple dots. And the closer they are to the x-axis, the better my line is. I can also go up and I can scroll over if I wanted to, and I can see my residuals plotted here, okay? So basically, if I added all these up and I squared them, these are all my residuals. If I added them all up and I squared them, this would be still probably a big, big number. Yes, it would still probably be a big number. However, that big number would still be the least big number out of all of the possible lines that I can actually make in this scatter plot. That's amazing. That's incredible. I think that's so cool to just think about it. Okay, and the implications of it are great. One last thing. Are you ready? This is cool. Watch. This also gives you your R. What is that? That is your correlation coefficient. That's what we did yesterday, 9.1. Isn't that amazing? So no more do we just need to do, if I could do this though, I could do correlation coefficient, watch, x1 comma y1. Look at this, look. This is 0.916 because that 5 rounds that 1 to 6. But look at that R, look at where my cursor is. That's the exact same thing. So no more do we need to actually type in CORR and then x1 comma y1 to match my x1 comma y1 for my graph. I don't need to do that. That's what we had to do yesterday. But now that we know how to do the regression line on Desmos, all I have to do is just type in the regression line. I get my regression, and on top of it all, I get my correlation coefficient, how strong that line actually is. And in this case, this is a very, very strong line. Okay. All other lines that you can make with this data plot, all other lines that you can make for this scatter plot, okay, this will essentially be the best R. All other lines that you can make will have an R value that is around 9 or maybe 8 or 7, but it won't be this strong. This is the best correlation coefficient that you can get because this is the best line. This is the best regression line. Isn't that awesome? And Desmos does it all for us. So on Math Excel, you're going to be asked to, maybe given just one thing, find your X and Y, your slope right here, and then your y-intercept, or basically find your whole equation, your whole regression line. But sometimes they may ask you to find your regression line and your correlation coefficient. Well, in this case, all you have to do is just type in the regression line, and then you get your correlation coefficient and your M and your B. That's freaking awesome. Okay, so let's skip this and let's go to my next one. So example 1.2, we're going to be using this table now. Let me erase some of this stuff. So now instead of this table, okay, we're not going to be using that. We're now going to be using this table. So this table is here for reference, as you can see. So 1, 10, 5, 15, basically years out of school and annual contribution, right? And so this is my actual line. So let me go over here. Let me move this down. I'm just going to plot this. Zoom fit. Okay, so it's negative correlation, as we can see, yes. So negative correlation, obviously. That's fine. Now, let me change a couple things. Ready? This is my regression line. If I want to find the regression, because that's what it's asking me to find the equation of the regression. That's what it's asking right here. Find the equation of the regression line. All I have to do is change this 1 to a 2. Why? Because this is now y2 and x2. Okay? This is now y2 and x2. You see that? So this is now y2 and x2. So all I need to do is change this. Go over here, type in y2. Go over here, type in x2. And then they will give you your M and your B. Okay? They will give you your M and your B. All right? So what is your M here? Your M, let's write it down. Y hat equals, your M is negative 0.38 x plus, what's your B? 12.88. This is your regression line. What's your R? What's your correlation coefficient? Look at it right here. It's going to be negative 0.908. So negative 0.908. Didn't ask for that, but what we can do is we can find it. So that's a pretty strong line. It's definitely a strong negative correlation, just like what we discovered yesterday. And if I wanted to plot it, I can plot it, and then boom, there it is. That's your strongest regression line. That's so amazing. I think that's so awesome that we can just do this over and over and over again. So let's erase this. I hope that makes sense. Now let's go to example 2. This is now Old Faithful. We're going to be using the stuff from example 3. So let's go over here. I want to exit out of this. I don't want that anymore. Let's go over here, close that. I wanted from example 3 from 9.1. So this is my data from example 3. Let me go ahead and click it. And then let me zoom fit. Big amount of data because it's Old Faithful. So that's zoom fit. Awesome. So now, okay. So now what I want to do is I want to make my regression because that's what it wants us to find, right? So I need to do y. Now I have to go back up and I have to see, okay, well that's right here. See that? That is x sub 5. See that? X sub 5 and then y sub 5. So that means I need to make sure in my regression line down here, I do y5, just literally type 5 right after, do my little regression symbol, mx, and then 5, and then plus b. And then I get my regression line. So now, y hat, my actual regression line equals, my m is 12.48 x plus 33.68. This is my regression line. For kicks and giggles, what is my R? My R is 0.979. This is a very, very strong correlated data. And as you can see, awesome. Let's actually change this to be like black so you can clearly see it. Okay, so as you can see, this line is very, very nice. That's a very, very strong line. It's the best line possible. Isn't that great? This is awesome. Okay, so that's all I'm going to show you for regression lines. Now let's get to some applications. I hope that is very easy for you. Let's get to some applications. What if I wanted to predict Y values using regression lines? Can I do that? You absolutely can. Predicting Y values are meaningful only for X values in or close to the range of the observed X value. So sometimes you will have X values that are almost like outliers. They are what we call not significant values in order to predict Y values. So those are values that are kind of outside your general table. So if your general table is like, let's just say, 1 to 5, then yeah, if you get an X value of 6, that's kind of like an outlier, and it's really not significant because you really can't predict that much. So look at my Old Faithful data. Look at this table. Look at my X values. I go from 1.8 to about almost 5. So if I can predict 5 if I wanted, I could definitely predict 5 if I wanted. I'm going to show you how that works. Or I can predict maybe 5.5. But if I predict, let's just say 6 or 10 or 22, that's totally outside the bounds of 1.8 at the very top here, 1.8 at the very top of my X value to 4.6. If I wanted 20, that's totally outside the bounds. I don't want that. So that's what I mean by outliers. They will be outliers, and you don't want those values, okay? So it's very tricky on Math Excel. They may give you some X values, and they may say whether or not they may say, predict the Y value, but sometimes they'll give you the option to say not significant. If it's not within the bounds of your X values on your table, it is not significant. If it's not remotely close to the bounds of your X values in your table, it is not significant. So to predict Y values, let's get to the actual steps here. You want to substitute an X value into the regression equation. And then you want to calculate the predicted Y value. Okay? So how do I do this? Let's go to town on 2 examples. So example 3.1. Let's do this one first, okay? Example 3.1. The regression equation for the gross domestic products in trillions of dollars, the carbon dioxide emissions data is found below. So this is the regression line that we got, right? This was the regression line that we found, yes? You should all be shaking your heads, yes. Okay, great. So let's go back up here. This is what we had, right? So I'm going to click on this. I'm just going to type in my regression line real quick so I can get that, right? Type in my regression line real quick of the same thing. So this was my one there. Okay, perfect. So this is my regression line. See that? 166.9, and this is my regression line. Perfect. Okay, awesome. And they also give it to us right here. Now, what we want to find is we want to use this equation to predict the expected carbon dioxide emissions for each gross domestic product. For A, 1.2 trillion, and then B, 2.0, and then C, 2.5. How do I do that? Well, essentially, the easy way, well, actually, I would say the hard way to do it, is you're going to plug in 1.2 for X. You're going to plug in 2 for X, and then 2.5 for X. And you can definitely do that on the calculator, guys. You could easily do that right here. So you can say Y equals, watch this, 166.9 times 1.2, and then plus 115.725. I'm just copying down my regression line, and then I would get this. So this would equal a Y equals 316.005. Okay, so that would be my answer here. Or watch this. This is amazing. You could do it that way, or watch this. Ready? You could type in your equation. Just type in Y equals 166.900x plus 115.725. Okay? Type that in. Now that I have it in, ready? Let me actually close example 3 down. Give me a second. Okay. So those are the same line. Blue and purple. Yeah, they are the exact same line. See that? They're the exact same line. Okay. Let me go back up here and plot the points and then do that. Okay, so that's my regression line, yes? Watch. Once I type in the function right here, you see how I typed in the function, all that function? All I have to do is go up to here to settings, and then what I can do is I can go back down here and say convert to table. If I convert this to a table, what happens is this. Look at that. It automatically calculates this data for you. So all you have to do, ready? Watch this, guys. Watch. All I have to do is type in 1.2. What is that? What is that? That is your answer that you got right there. It's the exact same thing. Isn't that awesome? So now watch. All I have to do now is type in 2. Now 2, of course, is right here. Okay, it's the exact same thing, but all you have to do, they give you the basic data sets, -2 to 2. But I can type in 2, and that's what it is. So I'm going to go over here and say y equals my predicted y value, y hat for 2.0 trillion is 449.525. That is awesome. Okay, and then if I want 2.25, I go over here and just type in 2.5. Just go over there and I say that, and so my y hat equals 532.975. And it's as simple as that. I could also, like I said, just go over here and just erase that to be 2.5. And then I get the exact same thing. I'm just plugging it in for x. But this is a way faster way to just type it all out, type the actual equation out, and then convert it to a table. So that way you can just kind of zoom it in, and then you can actually just type stuff in, and then it pops out the answer all automatically for you. That's amazing. That's amazing. Okay, so let's erase this, and let's go to my last example here. So regression line for Old Faithful. So let's erase that. Let's erase this, and then let's go up and then erase my regression line here. And let's go back down to Old Faithful. You ready? So example 3 was Old Faithful. This is my Old Faithful data, yes? So this was y5, and then I'm just doing my regression line here. That was my regression line, yes. Okay. So now let's go down and let's hit enter. My regression line was y equals 12.481. They even tell me in the slide here. Okay, 12.481 x and then plus 33.683. Now watch what I'm about to do here. Ready? Ready, ready, ready? I'm going to take this and I'm going to go up to settings, and then I'm going to convert it to a table. Not that, don't duplicate, just convert to a table. Okay? So convert to a table, and then boom, you'll get it converted to a table. Now, what is it asking us to find? Use this to predict 2 minutes for A, and then 3.3 minutes for B. So 2 minutes, I already have that right here. See that? See? 5.645. So I'm going to have a y hat value of, 58.645. That's about the time. Predict the time until the next eruption. Okay, I think that's in days, I believe. Okay, now B, if I want 3.32, all I have to do is click underneath it. So see where my cursor is blinking, 3.32, and then it automatically calculates it for me. But let's round that. So this is y hat equals 75.12. Let's just round it there, about 75 days. Perfect. Isn't that awesome? I think that's just amazing math. I think it's so brilliant and so just inviting almost. So I hope that lesson kind of made you a little happy, because it really just is plugging it into Desmos over and over and over and over again, using Desmos constantly. Okay, so let's erase that. Let's go back. Awesome. So let's find out what we learned. What did we learn? Well, we learned how to find the equation of a regression line, find the predict, and how to predict y values using the regression line equation. But we also learned how we get the regression line using what we call residuals. Okay, guys, it's been an amazing ride. This is the end of statistics. This is the last lesson of stats. You have a couple of other activities this week and the test this week to review and to prepare for. And then after that, you have the final exam. Guys, this is Mr. Carlson. I hope you are making good choices, and I hope to see you in my next class. See you guys later. Be sure to like and subscribe.